All right, so we've got the setup here for case number 2, now actually performing case number 2. Using the law of sines on this new triangle with the same angle, the same big side, the same little side that they gave us before, let's figure out those other sides. So this is angle B, so let's also figure out how big side B and angle B are. Now we've already got the 105.8 stored in our calculator right now. Or at least if you don't, go ahead and store that as angle C. And while I'm thinking of it, I'm going to write it up here. Angle C for the first case was 74.2 degrees, but for the second case, it's 105.8 degrees. So if I add that to angle A, which is 60 degrees, plus 60, and subtract that from 180, that's got to be how big angle B is, which is 14.2 degrees. I'm going to write that up here while I'm thinking of it. So on that first case it was that big, and the second case 14.2 degrees. I should have left myself a little more space up there. And while I'm thinking of it, in case I need it later on, I'm going to go ahead and store that as alpha B. I don't really need this the previous angle B that we had before, because I'm now using the second triangle here. Okay, so then if I figure out how big side B is, side B over the sine of that stored angle 14.2 equals side A divided by the sine of 60 degrees. So B has to be 9 times sine of that stored 14.2 number over sine of 60. Now if it helps you, rather than writing 14.2, maybe that's too tempting for you to type in your calculator 14.2, maybe I'll put a B and then I'll put like a little star there to help me remind myself, oh yeah, I store that as angle B. So then 9 times the sine of stored angle B, close the parentheses, divided by the sine of 60, close the parentheses. This new side B is going to be 2.5, about 2.6 actually. So side B, 2.6. So look at all the things that changed, right? That when I move this side inward from where it was out here, then this side this side actually just moved to the 9. But this angle is no longer this size. This angle can go into this one, but this one is always going to be supplementary to that one. Those two will always be supplements. So you don't have to draw all this out. You just know this angle is going to have to be supplementary. And then this side length had changed in here as well. So a lot of things changed when you had this ambiguous case. Let's look at another example, because I don't think one is really enough to sink it in. So angle A, I'm going to try and force it. I'm seeing, oh, they gave me an angle and a side and a side. Is that an angle big side, little side, or is that just an angle and then followed by two sides? So angle A, 58 degrees, side A, 11.4. Let's make this the 12.8 sides, and then I can see, is this an angle big side, little side? Yes, it is an angle big side, little side. Dang it, those are a big pain in the angle big side, little side. So with that, let's see, let's come up with, well, based on that triangle, let's see if we even get a triangle out of this. Hopefully we get an error, and that means that we don't have any triangles. If we don't get an error, though, automatically that means we have two triangles that we can make here. So if I take, let's figure out how big angle B is. So sine of angle B divided by 12.8 has to equal the sine of 58 divided by 11.4, using the law of sines there. Multiply both sides by 12.8 and then take the arc sine of 12.8 times sine of 58 over 11.4. Try typing in your calculator, okay? Good practice. 72.2 degrees. 72.2 degrees. So I didn't get an error or anything. That must mean that we're going to have a second triangle here, okay? So there is going to be a case 1, and there will be a second case. Now, I stored that as angle B. Or actually, I didn't. I'm going to do it right now. Store as angle B in my calculator. I'll put a B star here to remind myself. I stored that. And then to figure out how big angle C is, let's subtract, well, let's take 72.2 plus a 58 and subtract that from 180. So plus 58, 180 minus that answer, and I'm getting 49.8 degrees. So angle C, 49.8 degrees. But it's not exactly that, right? I've got to store that number as C. Store as C. If you don't have a calculator that stores, man, you really need to invest in one. You might as well just go ahead and get a graphing calculator, because starting next year, you have to have one anyway. Okay, so with that, we have that stored as angle C. Now let's figure out how big side C is. C divided by sine of that stored angle, maybe I'll do what I suggested, putting C star for the stored angle, has to equal side 11.4 divided by the sine of 58. So side C has to equal 11.4 times the sine of angle C over sine of 58, which is, type in your calculator, man, these take a lot of concentration. So side C is 10.3 approximately. 10.3. And that was our last one for the first case. Now moving on to case number 2. Case number 2. Okay, if I kick in that side, it's going to come somewhere in there, and then we're focusing on a triangle that looks like that now. Remember what we said? This angle is supplementary to this angle out here, because this is an isosceles triangle, so this angle is 72.2 degrees. Okay, so this angle is 180 minus 72.2. Which that was not an exact 72.2. Remember, we stored that number as B. So let me redraw that triangle down here. So angle A is 58 degrees, side B 12.8, angle C, and this is, if I do 180 minus that stored angle B, this supplement, this angle is 107.8 degrees approximately. So I'm going to store that number. I'm going to replace this angle B with this new angle B right there. So store that as B. And then angle C has to be 180 minus the parentheses, the sum of 58 plus that stored angle B. The 107.8. And I get that angle to be approximately 14.2 degrees. And while I'm thinking of it, I'm going to go ahead and store that as C, as angle C. Okay, so we got some stuff to fill in up here. So our new angle B for the second case, it was 107.8 degrees. And our new angle C was 14.2 degrees. So the only other thing to figure out is side C. So I can just use the law of sines for that. So sine, actually we need to figure out side C divided by sine of our stored angle C has to equal side, let's see here, didn't we have side A? We did have side A, I just forgot to mark it. This side is 11.4, this side's also 11.4, 11.4. So 11.4 divided by the sine of angle A. Multiply both sides by sine of C, and side C is 11.4 times sine of sword C, close my parentheses, divided by sine of 58, 3.3 for side C there. Okay, a lot of work, but really I need to see all of these steps that I just showed you to get the full credit. Okay, I promise this is the last one here. So this is alpha, by the way. It's opposite side A. So if I draw my triangle, alpha is 50 degrees. Side A opposite that is 3. Side B is 2. I'm seeing here we've got an angle little side, big side. Oh wait, this is not an angle big side, little side. We have an angle little side, big side. So you can just use the law of sines on there. So there's only one kind of triangle that can be made with an angle little side, big side. I don't have to worry about the big pain in the angle big side, little side. So just do the law of sines on this. Maybe I'll call this beta, being that we seem to have alpha for one of them. Side C, and then I'll call this angle gamma. If I do the sine of gamma divided by side C. Oh wait, we don't have side C. Can't do that. Don't have that matched up. Got to figure out angle B or angle beta first. So sine of beta divided by 2 is the sine of 50 divided by 3. And then you could figure out how big beta is from there. And then you could figure out how big gamma is from there. And then afterwards use the law of sine to figure out how big C is. I'm sure you guys could be able to do all that, so I'm not going to do it. But don't forget that if it's not an angle big side, little side, you don't have two cases. But be checking, because I'm not going to tell you, oh, this is an ambiguous case. You could have two triangles here. I'm not going to tell you that. You're going to have to check to see, based on the information they give me, is this the ambiguous case? In this case, it was not. So we would just use the law of sines like normal. Well, that's it for Trig Day 9, and hope you like the angle big side, little side stuff. This is April Rainey, and I am signing off.